Good morning, students. In today's class, we are going to discuss some introduction on satellite communication. We are also going to see what is the need of satellite communication in the modern era of many advanced communications, and what are different satellites, particularly in the history of Indian era. What are different satellites has been launched by India, and what are the satellites India has launched by borrowing from other countries, and what are the applications of those satellites launched by our country. That we will briefly discuss as an history of satellite communication. In addition to that, we are also going to see that some laws of satellite communication which was given by Kepler. Uh, he is the Newton of satellite communication, who has given the basic laws of satellite communication, and still we are following his 3 laws of satellite communication. So in this course, we'll try to solve some problems. So I request all of you to sit with calculator, because I will ask many problems and you have to solve and answer the questions. These problems are very basic problems to make you understand about the applicability and the physical concepts of satellite communication. To begin with, again, I have a general question. What is the need of space communication when the modern era of communication is much advanced digital communications like mobile communication and many things? So if you see the modern days communication, we are using mobile communication. So look at uh, let me see whether it is. Okay. So see, I have 2 different mobile base stations, and we know that 2 base stations are communicating with each other by microwave link, and the microwave link is a line of sight communication. So if you want to establish a communication link in between 2 microwave stations, it is an inherent requirement that 2 base stations should be point to point alignment. So there should not be any obstacle in between them, so that a proper line of sight communication link can be established. So that is happening in case of radio communication. We are using mobile communication based on that also, or any other communication like television communication. But problem happening, the globe, our earth is very big. If you want to make a communication link in between India and USA, so both countries, India and USA, they are almost opposite part of the globe. Even completely not opposite, but somehow they are opposite part of globe. India is located somewhere here. The USA, they will be located some other part of the globe. So if there is a base station in India at this particular point, the other base station in USA may be somewhere here. So it is very difficult if you want to establish a line of sight communication between 2 different base stations. It is quite impossible, because there is the earth surface which is coming in between 2 different transceivers, so that a communication link cannot be established. So one ultimate solution of this is can we do like this? We increase the height of this base station, and we increase the height of it's not appearing in my screen like this, so that now I think it is possible to establish a line of sight communication between two different base stations. Sorry. Okay. So it seems to be possible, but if you think about the height of a base station, then is it possible to design such a base station which is having longer height? Particularly our base stations are ranging from 100 to 300 meter of height. Okay. So let us take a quick calculation that if we want to uh, establish a communication link in the geographical land that is India, then how much such kind of transceivers we require, and how much investment we need. Particularly if we talk about the installation of base station, I may not be correct actually. Hopefully we have to invest 20 lakhs of rupees in order to establish one base station. So pardon me if I am wrong, but somehow it is approximately that amount. So in order to establish one base station, we need to invest 20 lakhs amount of rupees. Okay, so let us assume that in the geographical land of India has a coverage of 2000 kilometer from north to south and 2000 kilometer from east to west. So in an approximate, as we have taken, so the total area of the geographical land will be 2000 kilometer multiplied by 2000 kilometer. So that will give us 4 into 10 to the power 6 square kilometer. So that this is coming out as the total geographical land area of India. Now, if you take on base station and the base station which is transmitting up to a radius of 1 kilometer, I am taking approximate value 1 kilometer. So sometimes some base stations are there which are transmitting up to some 500 meters. Some base stations are there which are transmitting up to 6 or 7 kilometers. Okay, it has a range because nowadays in modern communication, when we are moving for higher generation and higher frequency bands, then the coverage of the base stations are gradually decreasing. Okay, so that's why you know that in recent 5G auction, Reliance Jio has purchased 700 megahertz spectrum, because if they can take the 700 megahertz spectrum, 700 megahertz spectrum, that is the most costliest spectrum, and Jio has purchased with heavy amount. The reason is that with 700 megahertz spectrum, they can increase the coverage. Whereas if you are going for 1800, if you are going for 2300 megahertz, okay, so your coverage will be limited, like it will be some 500, 1 kilometer like this, the coverage will be. Okay, so anyway, that is the different thing. So if you consider the radius of the base station, then take it as approximately 1 kilometer, then how much base station we need to provide a coverage of 4 into 10 to the power 6 kilometer. So that we can divide. So we can calculate the area of this base station or the service area of this base station, that is pi r square, which is coming like this. So the total area we have calculated 4 into 10 to the power 6 divided by this pi r square. So it is coming out 1.27 billion, million. So these many number of base stations we need if you want to establish a continuous communication throughout India. And if we think that we need 20 lakhs of amount to build up one base station, so you can calculate how much investment we need. So it is not quite possible. Okay. So what is the way or what is the solution of this? The solution is, if we can, if you want to establish a high coverage, then we can go for an antenna which is having high length. Or antenna is nothing but, antenna is also called as a repeater. So it receives the signal and process the signal and again transmit the signal. Okay, so the solution is, instead of taking a small antenna, if we can establish a larger antenna like this, then this antenna which is located, or this receiver which is located at a larger height, it has a coverage of 1/3 of the globe. So by establishing or by installing an antenna with a larger height, we can cover 1/3 part of the globe. And similarly, if the same receiver will be established here, then it can provide another 1/3 of the globe. And the same antenna, if can be established here, then the last 1/3 of the globe can be covered. So in this way, by using 3 different antennas, and those antennas which is located at a high altitude, it can provide the coverage to the whole globe of the Earth. So what is the height then? So we have seen that if that height can be of 36,000 kilometer, if you can launch, or if you can install an antenna, or if you can install an transceiver, or if you can install an repeater, okay, at an altitude of 36,000 kilometer, then one antenna can provide, or one repeater can provide a coverage of 1/3 of the globe. And in this way, we need only 3 different repeaters to provide the coverage throughout the globe. So that is an idea which the scientists have discovered for the permanent solution of the above mentioned problem. So what we are going then? So instead of building such impossible tower, when we talk about this 36,000, when you talk about this 36,000 kilometer antenna, so it is quite impossible to build an antenna which is of 36,000 length. So what they thought, that instead of building such a large antenna, they try to send one repeater. They try to send a repeater at an altitude of 36,000, and the repeater will be there, and the repeater will remain present there at a location of 36,000 kilometer altitude. And as the Earth moves around itself, the repeater will move around the Earth at the same speed that the Earth is rotating itself. So that repeater, we call it as satellite. So satellite is a repeater which is located at a larger height and acts as a transceiver that provides the coverage of a large geographical area in comparison to the modern day base stations. Okay, so in this way, the scientists have thought to replace the base station with a satellite, but there is no physical establishment in between the satellite and ground station. But by removing the physical establishment, we remove that physical establishment by RF link. All right. So it was in the year 1945 when the scientist Arthur C. Clarke, he wrote a a paper regarding this statement to launch a satellite at an altitude, at an higher altitude, so that by using the satellite we can provide communication. And particularly, I am telling this is the time 1945, the Second World War is happening, and the Germany was attacking over Britain heavily, because Hitler was attacking heavily, and at the same time, the scientists were enjoying or cheering up with this idea. So rather than thinking about the attack what the Germans or the Hitler is doing over Britain, they were cheering up because of this idea that this is a brilliant idea. They can establish a communication link in between two different stations which are located at a far apart from each other. So these satellites are called the geosynchronous satellite, and which are to be launched in the orbit that is called geosynchronous orbit. So in due course, we will come across what is geosynchronous is called. What is the meaning of geosynchronous? So this is the idea of this Clark in the Second World War time. So this is one of the picture which I have collected. This is the picture of INSAT, one of the satellite. Here, the image collected by the satellite INSAT. That is one part of the globe. If you see, when the satellite is taking the picture of this part, even you cannot able to see the other part. That means USA and other countries, they are not visible. They are coming to be that part of globe. Correct. So if you want to establish a communication, suppose there is a satellite, and this picture was taken by the satellite. This satellite is called INSAT. Okay. So in India, there will be one ground station. Okay. So if this ground station in India want to communicate with another ground station, which is located somewhere in the globe, then it can only be done if that ground station is simultaneously visible to the satellites. Otherwise, it will not be possible. What I mean to say is that whatever the image you are seeing, this is called the field of view of the satellite. That means what do you mean by field of view? How much portion your satellite can able to see? That is called field of view. So this is the particular area, or this particular area is coming within the coverage of the satellite. So any of the base stations which are located, sorry, let me correct myself. I am not, I will not tell base station, rather I will take ground station, because base station is the term which we are using for mobile communication, but in satellite we call the base stations as ground station. So whatever ground stations are present in this particular area, those many ground stations will be able to communicate with the satellite. So if one ground station is located in Karnataka over here, want to communicate with any other ground station, suppose it is located somewhere in the Gulf countries like here, then both ground stations should be coming under the field of view of the satellite. So what is happening in basically, this ground station will transmit the information to the satellite, and the satellite will transmit the information to the ground station. But if any ground station which is present in USA and any ground station located in Karnataka wants to send some information to that, then it will not be possible, because it should be visible. So that is what it is written. Any station that can be that can see INSAT can communicate with other stations that also see the same satellite. Otherwise, it is not possible. Okay. So this also, for communication also, it is only possible between the stations under the same satellite visibility. Okay. Now come to the brief history of satellite communication. The first commercial satellite is called Intelsat-1. If you see, look at the picture of Intelsat-1. It's a very small satellite that time. I hope it was in the year of 1965. Okay, so it has a mass of 39 kg and it has a life of 18 months. So it is 18 months means around 1.5 year life. So the application of the satellite is for broadcasting TV channels, and it operates at 7 dBW RF power. So you know what is dBW. Indian Intelsat Earth station set up at Arbi near Pune. So our ground station is at Pune, which was established in 1971. And we have an antenna there at Pune I am talking about. The antenna is having a diameter of 28 meter. Just imagine what is the diameter. 28 meter is the diameter of the antenna, and I'm talking about the ground station antenna. It's not about the satellite. It is the ground station which is located in Pune. Okay, and it operates at a power of 3 kilowatt, which is designed by ISRO. So keep in mind that focus, you just remember this one. It was the mass of 39 kg, the first commercial satellite. Then coming to the next version, that is Intelsat 10. So 10 is the version of Intelsat. So you see what the weight in the previous first commercial satellite, it has the mass of 39 kg. Now it is increased to 5.5 ton. Okay, and which is launched in 16th of 2004. So the size of the satellite is gradually increased. So what the size of the satellite increased by using some advanced power amplifiers, by using some different solar plates. Okay, so you can see the size of the next generation satellite, which is very heavy satellite. Now see, this is one more satellite. It is called Inmarsat 4, which was launched in 2005, which is of weight 6 ton, and it was launched for mobile communication. Okay, and it has an EIRP of 67 dBW. I will tell what is EIRP is, effective isotropic radiated power. You see the ground station is here. It's a small computer-like thing, and it has a mobile. And you see, this is the antenna of the satellite, and this is the solar plate. So how big the satellite is. And one more satellite, it is launched by Thailand, that is called Thaicom 4, or it is called IFSTAR. And it was used for broadcast communication using two bands like hybrid K and Ku band. So this satellite operates either in K band or in Ku band. So it was launched in 2005. It has an approximate weight of 6 ton or more than 6 ton. It has a life of 12 years. Okay, so if you see the ground station antenna, let me go to the first generation. Don't forget, the ground station antenna has a diameter of 28 meter. Okay, so keep it in mind, and we will derive some conclusion from that as well. So this is one more satellite that is called Thureya. So you people might have not known aware about this particular satellite, but this particular satellite is, and it was and will always remain in Indian history. It has brought so many life threat to India. Have you remembered the Mumbai attack happened in 26/11? Mumbai terrorist attack. So the terrorists have used this particular satellite, Thuraya. So the terrorists have used this particular these many satellite phones to communicate among themselves. So you can just imagine what is the size of ground station. Sometimes, some days, the ground station size was somehow 28-meter diameter, and now in modern days it has reduced to such a small size. So there is a trend, if you see, that as the satellite size is increasing, the size of the ground station is decreasing. I will show one more interesting picture. Yeah, this particular thing, you just look. Yeah, it happened in 1975 and 76. Okay, so this is one more satellite. It is India has borrowed. Okay, from NASA. This is ATS-6 NASA. Yeah, EIRP of 51 dBW, and it use a antenna of 30 feet parabolic reflector, and the receiver is having 12 feet parabolic dish. Okay, so I don't know whether you people have seen this kind of dish antenna, which in our childhood we have seen for television broadcasting and all. This kind of antennas are there. Now some places people are using also this kind of big antennas. Okay, but nowadays it is less preferred. Okay, this image, if you see in the rural areas, there is a TV, there is a big antenna over here, and some people are watching some TV. So it was in the year of around 1975 somehow. And at that particular time, the cost of this antenna, this receiver, was about 10,000 rupees. That is the cost of each receiver antenna. Okay. So do you know that how much amount you are spending to purchase one receiver antenna? Nowadays we are purchasing DTH, you know, we are purchasing Tata Sky, we are purchasing what else? Sun Direct, we are purchasing that is what other one, this antenna. No, so how much amount we are spending? 1,500, that much? 2,000 maximum. So just pay 1,500 and bring on receiver antenna. That's it. But time was there, we were spending 10,000 amount for this. Let me see, something has come in chat. All right. So that is the type of receiver we are using. Actually, thing is that the scientists at that time realized that India is a large geographical area. And during that time, India does not have that much infrastructure, that India does not have the much advanced medical equipment. India does not have good educational institutions, and healthcare services all are lacking in India. So if we want to dream for an advanced or modern India, then we have to connect each and every part of our country to the technology. If every corner of our country will be connected to technology, then we can dream for an modern India. So with that concept in mind, scientists have thought that why distance education cannot be provided to the rural India people. So to provide the distance in education, they have thought of an antenna which is of costing around 10,000 rupees, so that the people are gathering at some particular location, and they could able to listen, or they could able to learn something like this. So from that, yeah, you know, that time government has plans around 2,400 underdeveloped villages in Rajasthan, Madhya Pradesh, Odisha, Andhra Pradesh, Bihar, and Karnataka. and they connected with this distance education program, which having hub at Ahmedabad and Delhi. So the informations were broadcasted from Ahmedabad or Delhi, and the people at other locations, these 2,400 locations, could able to collect the information or could able to see the information and get the information at different locations. Okay. Now, from that concept, they have thought that why DTH cannot be done. So this concept of DTH has came into their mind from this particular idea. All right. So coming to the next, this is one of the other satellite which also borrowed by ISRO or India in the year 1977 to 1978, and particularly it is a Germany satellite. The name is Symphonies. India has purchased from Germany, and it is particularly a telecommunication satellite. And during that time, now the telecommunication is done by Department of Telecommunication, DOT, and that time it was not there. So P&T, it is an organization who was handling all the telecommunication in India. So yeah, they have, let me show that image. Can you see this image? See, a big antenna which is installed on the back side of a vehicle, Volvo bus. Okay, so this bus rotates everywhere across the geographical area of India. Okay, so you can see different technologies has been done, and concept of SNG and SAT-based internet in 1970. What is the full form of SNG? It is the satellite. I forgot the full form of SNGs. Satellite news gathering. Okay. Now the concept of satellite news gathering has evolved from this particular idea. Nowadays, if you see many news broadcasters, if you see Aaj Tak, if you see G News, if you see India TV and many more, okay, every news broadcaster, they are having a vehicle like this and they have installed one antenna like this. So the concept of SNG or satellite news generation, I think satellite news generation, that idea came from this concept, from this particular satellite. So what they are doing, that they are collecting the information from different parts. Okay, if anything happens in any particular location, the news broadcaster, they rush to that particular location and collect the information, and immediately they transmit to the satellite. But nowadays, what we are doing, we are watching the live. If something, even all and every news broadcasters, they are showing the live broadcasting of any event. So that is being done by this SNG satellites, not satellites, this SNG receivers or the ground stations. Okay, so one more satellite that is called Apple. Okay, so yeah, you see it is what? Goodbye Newton, welcome Apple. Okay, so there is a relationship in between Newton and Apple, because Newton has come across his 3 laws by looking at apple falling from the tree. So this is the satellite which was launched by India. Again, it is a communication satellite, and it is not also India's own satellite. Again, India has purchased this satellite. So this is the image of that particular satellite, and it has many applications as mentioned over here. And And particularly the application of this particular satellite is management of the orbital. That means it has a different unit, so that whenever we are launching a satellite, how the orbital motion can be managed. That means we are launching, for example, I will show this particular image. We have so many satellites. Okay, I will show in the next slide, not in this slide. We have so many satellites. This is the image I am showing. This data is up to 2008. Okay, so it is very, very old data I am showing. Nowadays, we have so much satellite, many more satellites we have. So are different, uh, longitudes. Okay, 48 degrees, 55 degrees, 74 degrees, 83 degrees, and 93 degrees. So many satellites which are rotating across the Earth. Okay, so different satellites which India has launched. Okay. And further, we have launched so many satellites because this data is up to 2008. So we have some limited amount of satellites here. Now you see yeah, this particular image which I was telling to show you. So this is the Earth, okay, and the satellite is launched at this particular point. So initially, when the satellite is launched, you can see how the satellite is launched into its orbit, how the orbital motion is taking place and orbital management is happening. When the satellite is launched, okay, it will rotate in an elliptical manner. Okay, so when it rotates, when it completes one elliptical rotation and it comes to this particular point, there is LAM firing happens. Okay, so LAM stands for a liquid, A stands for altitude or something, I don't remember. M stands for motoring. So LAM firing happens. So when LAM firing happens, the satellite changes its orbit. So earlier it was not rotating. When it is launched recently, it follows this particular orbit at this point. Okay, so thing is that immediately satellite will not go to its orbit. Okay, it will follow some path. Gradually, it will go to its final orbit. So then it goes here and LM firing happens, then it comes here. So when it comes, it will open one of its array or antenna. Not exactly it is called antenna. This antenna is called the solar panel. It is not antenna actually. Antenna is different, which is used for communication. This is the solar panel. Solar panel we need for power because satellite is launched there. Satellite needs some power to operate because we cannot give direct power supply there. So it has to collect power from sun. So we have a solar panel. So one solar panel will be open. Okay, then again it will rotate like this. Then other solar panel will open, and gradually the antennas, you can see the antennas are also opening. Okay, so in different stages of the rotation, different activities are taking place, and finally the satellite will come to its original orbit. So once the satellite comes to the original orbit, then and during that phase, some of the payloads, they will be removed. Okay, the satellite will remove, because when the satellite will launch, the satellite will not go, some rocket will carry the satellite. Satellite itself cannot go. Okay, a rocket will carry the satellite, and when the satellite that is called Polar Satellite Launch Vehicle, PSLV, and GSLV, different launch vehicles are there. So gradually some parts of the satellite, which if any part means job of one part is over, then it will be removed from the satellite, and in the final orbit, only the satellite will be launched and other parts will be removed. Okay, then the question comes, if when the other parts are removed, then what happens to those parts which are removed, and what happens to the launch vehicle? Does the vehicle come back to the original place? No. The answer is, once the satellite is launched, if a launch vehicle is carrying the satellite, the launch vehicle cannot come back to the ground station. it will be simply destroyed. Okay, and if it is destroyed, then where it is falling, it will fall, because we know 2/3 of the globe is covered with water. And yesterday we were I had a fundamental question, that why if you see that um, all the launch pads across globe, US has a launch pad, India has it, Russia has, China has, and every country is having launch pad, satellite launch pad, and every launch pad will be located in the east, near the seashore, so that the redundant parts, they will fall in the sea. So that is the reason why every satellite launch pads are close to or are located near the sea, and the satellite will be launched to launch in the eastward direction. Okay. So this is the fundamentals of that is satellites and their brief history. Now come to the laws of planetary motion. So one of the great scientists, who is Kepler, he gave 3 laws of satellite communication. So basically, Kepler was not earlier a scientist, because Kepler was working under one scientist as an assistant. Kepler was an assistant of one scientist. So the scientist under whom the Kepler was working, that scientist, he is a very good observer. So that is the quality of any scientist, to observe something. So he observed some planetary motions. Planetary motions in the sun's sense, how Earth is rotating across sun, how moon is rotating across Earth. So all the planetary motions he observes, and he make a note of that. And by the time he became dead, so Kepler, who was working as as an assistant under him, so he got all those observations, and Kepler himself come out with 3 laws from those observations. So the first observation what Kepler gave, the planets orbit in elliptical path with sun at focus. So every planet orbits in an elliptical path with sun at focus, keeping sun at focus, every planet orbit. So that is the first law of Kepler. That is same is true for satellite also. When the satellite is rotating across Earth, the same statement is valid. Second law what Kepler gave, that is the line joining a planet to the sun sweeps out equal space in equal time. This is a very important law. The line joining a planet to sun, this is a planet. Okay, so the planets can be 2 types, either artificial planet or natural planet. Earth, Moon, these are the natural planets. Satellites are the artificial planets. We are launching the satellite. So the line joining a planet to sun sweeps out equal space in equal time. Okay, for example, if the planet is here, for some amount of time, suppose this planet was earlier located here. After some time, let that time be t, capital T. After some time, this planet has reached at this particular point. So in between this time interval, how much area, this much pink color shaded portion area he has covered. This much is the area. Now when the same planet moves to this particular point, and if we make an observation at the same time, how much he had spent there, for the same time t, the planet will reach here. And how much is the area? This much is the area. the planet has covered at a time of capital T. That implies whatever area the planet has covered at a time T when he was located at this particular point, the same area he covered at this particular point at the same time interval T. Whereas if you observe, what about the distance? When the planet was traveling from this particular point to this particular point, the distance covered was very less. But if you see here, the distance traveled by this particular point is very large. The distance covered or the distance traveled by the planet may be different, but one thing is common, that is for equal time, they cover equal area. So what is the conclusion? The conclusion is that when the planet is located at a longer distance from the um, from the sun or central object, when it is located at a longer distance, then it travels with less velocity. When it is located at near the sun, then it travels with high velocity. So that is the second law. Velocity of satellite is lower at apogee and higher at perigee. So this is called apogee. So you just remember this particular point. It is related to satellite communication. When the planet is away from the satellite, that particular point is called apogee. When the planet is closer to the satellite, that particular point is called perigee. So at perigee, the satellites travel with higher velocity, and at apogee, the satellite travels with lower velocity, such that the area covered by the satellite at some time interval t will become equal. So that is two different laws of satellite communication. So in the next class, when we'll meet, we will discuss the third law, and we will take up some examples, and I will give some quick calculations to do based on the third law of satellite communication, or third law of Kepler.